Attach an eye bolt to the upper metal, attach a cable to the eye bolt, and take out the upper metal using a chain block. After the upper metal is taken out, insert the lower metal drawing out pin into the crankshaft. Turn the crankshaft in the ahead direction. When the crankshaft is turned 180 degrees and the lower metal appears, attach an eye bolt and take out the lower metal in the same manner as with the upper metal. When assembling the main bearings, tighten them according to the procedure you see here. On the 45 LA engine or above, tighten the main bearings according to the hydraulic pressure shown here. On the 37 LA engine, tighten them to the nut rotating angle of 55 degrees with a spanner. These are the tools you'll need to take out the crank pin bearings. Again, we're using animation to show you the procedure for taking out the lower part of the crank pin bearing. Turn the crankshaft and keep the crank pin at the position of top dead center. Then, using the hydraulic unit, loosen the crank pin bearing clamping bolts. In the next place, attach an eye bolt to the crank pin bearing lower part. Attach lifting pieces to the top of the door openings and pull both sides of the crank pin bearing lower part with chain blocks to prevent it from falling. Remove the nuts, pull out the bolts in the downward direction. Loosen the chain block and slowly lower the crank pin bearing lower part and take it out to the outside. Inspect the crank pin upper metal at a position where the crankshaft is turned from the top dead center to the bottom dead center side by 35 to 40 degrees while fixing the connecting rod and turning the crankshaft again. First, attach the metal stopper pieces to both sides. Insert stoppers into the holes of the column, and after turning the crankshaft, attach a band to the connecting rod and fix it. Then start the inspection of the crank pin upper metal. When reassembling the crank pin bearing, on the 45 LA engine or above, tighten them at hydraulic pressure of 640 kilograms per square centimeter, and on the 37 LA engine, tighten them to the nut rotating angle of 125 degrees using a spanner. These are the tools you will use to inspect the crosshead pin bearing. Again, the inspection procedure for the crosshead pin bearing is shown in animation. Place the crankshaft at the bottom dead center position and then loosen the nut at the top of the crosshead pin bearing by hitting it with a hammer. At this time, fix the mounting bolt of the crosshead pin bearing using a bolt to prevent it from dropping off. After removing the nut, attach an eye bolt to the top of the crosshead pin upper bearing and lift it up using a chain block. Set it at the top of the column. Turn the crankshaft to a location where the mounting bolt of the crosshead pin bearing can be removed. After removing the crosshead pin bearing mounting bolt, turn the crankshaft to top dead center and support the crosshead with the stopper. While carefully operating a chain block, bring the connecting rod down until the crosshead pin bearing can be seen. To take out the crosshead pin bearing, attach an eye bolt and take it out using a chain block as you see here. Remove the cover from the pump stand. Turn the crankshaft to the injection starting position crank angle of the cylinder to be adjusted. Drive the adjusting screw until the starting line of fuel injection matches with the plunging guide indicating line. Confirm the crank angle when the indicating line coincides with the starting line of the fuel injection by crankshaft turning, and then tighten the lock nut. Although the procedures for maintenance and inspection of Mitsubishi's UEC LA series diesel engines could not be completely introduced in this limited time, please perform the maintenance and inspection work of your UEC LA engines carefully and safely using the instruction book and this videotape as reference. Your daily careful maintenance and inspection will assure the continuous trouble-free running of your UEC LA engines.
In 1984, in its single-minded endeavor for technological improvement, Mitsubishi Heavy Industries developed the Mitsubishi MET-SC turbocharger, which far excels previous models in reliability and efficiency. The MET-SC turbocharger is designed to be compatible with all our 2-cycle and 4-cycle diesel engines. Now let us see how the Mitsubishi MET-SC turbocharger is opened up and reassembled. To begin with, let's look at the step-by-step process of an MET-SC turbocharger being disassembled. First, remove the flange from the tachometer cable lead-in hole. Then, attach a sling wire to the silencer. Remove the nuts. and hoist the casing to separate it from the turbocharger. Do this gradually, being careful not to damage the tachometer cable. Finally, remove the tachometer cable from the pickup. Remove the hexagonal bolts. And then fit the lifting pieces to the inner scroll. Screw the starting bolts into the inner scroll. Then sling the inner scroll with a wire rope and pull it out. First, remove the nuts. Then, fit the lifting pieces to the gas inlet inner casing and sling it with a wire rope. Screw the starting bolts into the gas inlet casing. Pull out the casing by the wire sling. During this overhaul, the nozzle ring is kept attached to the casing. Screw the rotor pulling out tube onto the rotor shaft. Attach the stay to the outer casing of the gas inlet. Insert the bolt into the rotor pulling out tube and screw the nut onto the bolt to prevent the rotor shaft from moving towards the turbine. Remove the rotor shaft locking nut using a hook spanner. Screw the hydraulic jack onto the rotor shaft. Connect the hydraulic jack and the hydraulic pump with a rubber hose. Close the hydraulic pump relief valve and raise the pressure until the pointer reaches the blue-colored mark on the pressure gauge. With the MET53SC type shown here as a model, the blue-colored mark represents 370 kilograms per square centimeter. Insert the handle through the hydraulic jack window to loosen the nut. Open the hydraulic pump relief valve. Remove the rubber hose from the hydraulic jack. Remove the hydraulic jack from the rotor shaft. Remove the nut. Then remove the liner. Attach the draw-out tube to the impeller. Screw the starting bolt into the impeller to pull out the impeller. Screw the threaded bars into the sleeve to pull out the sleeve. Then remove the attachment bolts from the support. Screw the starting bolts into the support to pull out the support. The support has a compressor side thrust bearing and compressor side oil labyrinth in it. Screw the threaded bars into the thrust collar to pull out the collar. Screw the rotor guide tube onto the rotor shaft. Remove the bolt previously inserted into the rotor pulling out tube to pull out the rotor shaft. Sling the rotor shaft with a wire rope. Remove the stay and pull out the rotor shaft gradually. First, fit the puller to the oil labyrinth. Then, screw in the starting bolts of the puller. Tighten the starting bolts. And pull out the oil labyrinth. Screw the threaded bars into the oil thrower and pull out the thrower. Screw the threaded bars into the turbine side journal bearing and pull out the bearing. Remove the attachment bolts from the turbine side thrust bearing. Screw the starting bolts into the thrust bearing. Tighten the bolts and remove the bearing. Screw the threaded bars into the compressor side journal bearing to pull out the bearing. This completes the MET-SC overhaul procedures. Now we will run through the reassembly procedure. Basically, reassembly is just the reverse of the overhaul procedure. But a thorough cleaning of the bearing and rotor shaft is required first. First, install the bearing. Install the compressor side journal bearing and apply lubricating oil to it. Apply lubricating oil to the turbine side thrust bearing and install it. Install the turbine side journal bearing. And apply lubricating oil to it. Install the oil thrower. Install the turbine side oil labyrinth. Reinsert the rotor shaft into the casing. Slide the thrust collar onto the rotor shaft. Apply lubricating oil to the compressor side thrust bearing. And install the support. Slide the sleeve up to the midway point of the spline, aligning the matching marks on the rotor shaft and sleeve. Slide on the impeller. Fit the impeller claw into the groove in the sleeve. Make sure that the matching marks on the sleeve and impeller are completely aligned. Slide on the liner and turn the nut on loosely. Screw the hydraulic jack onto the rotor shaft. Insert the impeller and sleeve together using the hydraulic jack and raise the pressure until the pressure gauge pointer reaches the blue mark. Then fasten the nut. Remove the hose and remove the hydraulic jack. Next comes the measurement of clearances. Shift the rotor shaft axially to measure the thrust clearances. With a feeler gauge, measure the turbine blade clearance at 4 circumferential points, that is, at the top, the bottom, and both sides. With the feeler gauge, measure the impeller blade tip clearance. Also, at the 4 circumferential points, top, bottom, and both sides. After finishing the measurement of the blade clearances, make sure that the rotor turns smoothly. Also, don't fail to check for rubbing noises. The final step of the process is putting the silencer back in place. Connect the tachometer cable to the pickup. And finally, refit the silencer, being careful not to snag the cable. And refit the flange to the silencer. Now you've gone through the entire process of MET-SC turbocharger overhaul and reassembly. Mitsubishi Heavy Industries has been placing an emphasis on reinforcing its worldwide turbocharger service network. Its agents specializing in MET turbocharger post-sale servicing and maintenance are scattered throughout the world, with engineers and technicians trained in MET turbocharger overhaul and reassembly work ever ready to help the users. Mitsubishi Heavy Industries will continue